Alright, welcome to another section on sort of the conic sections, and this is something called hyperbolas. Okay, so hyperbolas, what are they? Well, once again, if you imagine that sort of conic section that we've been focusing on, we take a 3D object and then we place a 2D object in between it, and what do we get? Well, when we place this object straight down through the conic section, we get this image that kind of looks like two parabolas sort of shooting off from one another. And that is what we call the hyperbola. So what are some of the features of the hyperbola? Well, the features, we have foci, right here, and then we have our pxy. And what do we know about this? Well, the p is on the hyperbola if, what do we know? The absolute value of the distance, so this means distance, the distance from p to f1. Okay, so the distance from p to f1 minus the distance from p to f2 should equal what? 2 times a. Okay, so a hyperbola is the set of all points in the plane whose differences, the difference of whose distances from the foci is a constant. Okay, so no matter where we place that p-value on the hyperbola, the distance between these two values is going to be constant, which is really similar to what we had with an ellipse. If you recall that concept with the ellipse when we had the two sticks in the sand and then the string sort of in between it, sort of a similar concept, except these guys are actually the opposites of one another. So since they're the opposites, you'll notice that in the formulas for them. So the formulas for hyperbola with the center at, and notice here real quick, we're looking with the center at the origin, okay? So the graph of each of the following equations is a hyperbola with a center at the origin and having the given properties. So we're going to have the two opposite ones. As usual, one is normally focused on the x-axis and one is focused on the y. So if we have our equation here, and notice this looks really similar to what we had with ellipses. The main difference will be the sign on the inside. We have a subtraction now. Okay, so with the ellipse we had addition, and now with the hyperbola, the main thing to look for is that subtraction. So we have the x squared and the y squared. However, the numbers with the x squared and the y squared are not the same, so we know it's not a circle. And then we have a subtraction, so we know that it's not an ellipse. It's going to be a hyperbola. So now if we see that the a value, or the bigger value, once again a is always talking about the bigger value, if the a value is under the x squared, then what do we have? Well, we have the vertex with the x value, and the horizontal length is 2a, and then we have these items called asymptotes. Okay, we've seen asymptotes before if you've ever graphed rational equations, which I believe is usually in Math 103 and Math 135. And we also have them with the trig functions, once again with cotangent and tangent. So we have our asymptotes, they're guidelines, they're not actually on our graph, but you would need to draw them in when graphing. So we have our asymptotes right there. And then we have our foci, which come from the c value. It's very similar to how we found the c value with the ellipse. The main difference this time is the sign. Why is it a plus? Well, the foci are actually greater than the vertices. Okay? So the foci right here are on the outside. And those are the basic features of our hyperbola. Now the one thing to note, it is along the horizontal axis because we have the x value subtracting the y value. Okay, so the y is being subtracted from the x. So if it's switched in the other way, if we have the y value and the x value is being subtracted from it, then that's when we're going to have our hyperbola focused on the y-axis. So same thing, we'd have our foci over here. We find that using the Pythagorean theorem, kind of like before. And then we have our asymptotes, like so and like so, from our equation here. So now, sorry, I didn't mention that previously. So the equation is plus or minus b divided by a for this side of the parabola, for this side of the line, and then the other one, it's a divided by b. So if y is first, in terms of the equation, if y is first, then you'll have a on top and b on the bottom. If x is first, then you'll have b on top and a on the bottom. Okay, so some terminology. The transverse axis is the line segment joining the two vertices. So where is that? That is this right here, this transverse axis joining A and A. Okay. And then the center of the box is called the center of the hyperbola. So one thing you might have noticed going on here, we have this box that shows up. It passes perfectly in between the A value, the B values, and our asymptotes perfectly cross the corners. So it perfectly bisects the corners. And that what we call is the box for the hyperbola, and in the center of that box is called the center of the hyperbola. Okay, so this one's kind of complicated to graph, but if you follow a basic step for it, or basic steps, it should be pretty straightforward. So how to sketch a hyperbola? Well, one, sketch the central box. And once again, I mentioned that before, the central box is when you plot out the B and the A values, the positives and negatives, and then you draw your box in. This is the rectangle centered at the origin, with sides parallel to the axes. That crosses one axis at plus or minus A and the other at plus or minus B. Then sketch in the asymptotes. Right here. Sketch them in, make sure they're dotted. Okay, so you have those little dotted guys. These lines are obtained by extending the diagonals on the central box. Plot the vertices. Okay, so where are the vertices? Right here and right here. These are the two x-intercepts or the two y-intercepts. And then sketch the hyperbola. So start at a vertex and then branch out either direction. Please remember your arrowheads. And there you have. And then the last thing you would want to do is to draw in the foci, which it doesn't mention here, but you would draw that in here and here. The f values, f1, f2. So example 1, find the vertices, foci, and asymptotes for the hyperbola and sketch the graph. Alright, so let's take a look at this. So what do we know so far? Is this in the right format for solving? The answer is yes, it is. So we have our x squared and our y squared value. Then we've got that subtraction, and then we have the values underneath. So this is perfectly in the form for a hyperbola. How do I know it's not an ellipse? Because we have that negative right there, so it's not an ellipse. Okay, so from this, we can identify our a squared and our b squared values. Since the x is first, we have that a value underneath it, so a squared is equal to 4, b squared is equal to 16, which means that a is equal to plus or minus 2, and b is equal to plus or minus 4. And then real quick, since x is first, we're never going to be along the horizontal. Okay, that's just a small side note. You wouldn't need to write that on your work. Alright, so let's see. We have that. Now let's go ahead and find the foci. The foci, it's going to be c squared equals a squared plus b squared, a little different than the ellipse formula. Then c squared is going to equal, well, we have the plus or minus 2 squared plus the plus or minus 4 squared. So c is going to equal plus or minus the square root of 4 plus 16. So c equals plus or minus 2 root 5. So once again, that would be equal to root 20, which I simplified to 2 root 5. Alright, so now what else do we need to find? Well, we need our vertices. And the vertices come from the a values. So that would be plus minus 2 comma 0. Okay, so we've got our foci, our vertices, we have a, b values. What are we missing? Well, the main big thing that we are missing for a hyperbola are the asymptotes. Okay, so definitely keep that in mind, the asymptotes. Big things. The asymptotes for our equation, since we're going along the horizontal axis, we use y equals plus or minus b divided by ax. So that means y is going to equal a positive 4 divided by 2x, and then we can simplify that to y equals plus or minus 2x. Alrighty, so there we go. We have the main values. Once again, what are the main values? Your a and b values, right here and here. So let me change the color. A and b. Then your foci. Ooh, I should have written that as a point. So our foci are points. Those should be at plus or minus 2 root 5 comma 0. And note, I'll write this that's going to be approximately 4.5 for graphing. Once again, when you're answering, unless otherwise stated, answer is the exact value here, but for graphing we would use the approximate 4.5, which is why I wouldn't box the 4.5. Okay. And then we have the vertices, the other important thing, and the asymptotes. So these items, 1, 2, 3, 4, 5, are the 5 ones that would be good, or that I would be looking for grading. So let's go ahead. How do we graph this? Once again, the idea is to first put in the a and b values to create that box. I'll do that in blue. So I have my a and b values, and we don't need to label them. They aren't a point. If you've indicated them up here, that is good enough for me when grading. But I will be looking for the box when you're graphing, okay? So we'll be looking for the box, the asymptotes, and the actual graph. Next thing, what do we do? The asymptotes. I'll go ahead and graph those in green. Those will be y equals negative 2x and y equals positive 2x. So those go smack through the corners. So down 2 over 1, down 2 over 1, down 2 over 1. There we go. And then be sure to label these guys. And they should pass directly through the corners, so make sure you include that in your graphs. This is the y equals 2x, it's positive, going uphill, and y equals the negative 2x, negative because it's going downhill. Now we just need to draw in the other two items, our vertices and our foci. Okay, so our vertices, right here and here. So since these are actual points, we should label them. And then our vertices. What are our vertices? So it's about 4.5 and negative 4.5. 1, 2, 3, 4. So this would be negative 2 root 5, comma 0. 1, 2, 3, 4. Oops, I drew that on the wrong spot. 1, 2, 3, 4, 5. That goes there. And then 1, 2, 3, 4, 5. 2 root 5, comma 0. Okay. And there we have it. And once again, the foci aren't on the graph. They're just the focus point. So let's go ahead and draw in value here. Now notice the value does not cut into the box. It skims along the box and then it goes up onto the asymptotes, but it does not cut into the box. And there we have it. You have graphed your first hyperbola. Give yourself a little high five. Awesome. So once again, we have our main values, a, b, vertices, foci, and asymptotes. Make sure to graph your box, graph the asymptotes, and label the points and the lines. Now example 2. Find the vertices, foci, and asymptotes for the hyperbola and sketch the graph. Okay, so the equation we're given here, it's not in the perfect format. I'm not really certain what it is. It could be a circle, it could be an ellipse. So let's go ahead and first rewrite this correctly by getting the x squared and the y squared on the same side. So minusing the 9y squared to both sides. You know what? I'm still not convinced on what this is. I need to get the x squared and the y squared to be kind of by themselves. So let's go ahead and divide everything by 9 to get that by itself. And what do we have here? We have x squared divided by 9 minus y squared divided by 9 equals negative 1. You might be tempted to say, hey, we're done. This is a hyperbola. The y squared is bigger, so therefore we're going to be focusing along the horizontal axis. The answer to that is actually it's wrong. Why do you think that's wrong? Take a look at the right-hand side of our equation. Oops, and before that, sorry, that 9 should not be under the y squared. It should be a 1. Okay, so back to what I was saying. Take a look at that right-hand side of the equation. What do we see? Well, it's a negative 1. According to the equations that we have that are talking about hyperbolas, you're supposed to have a positive 1 on the right-hand side, and we don't have that. So we need to get that positive 1, and to do that, let's go ahead, multiply both sides by negative 1. We got to get this in the right format. So that'll be y squared minus the x squared divided by 9 equals 1. And for the sake of format, I'll go ahead and put the y squared over 1. So then the question here is a and b. We have our a squared should equal 1, and our b squared equals 9. So we have a equals plus or minus 1, and b equals plus or minus 3. Okay, so we found our a and b values. Awesome. What do we need next? Well, we still need the vertices, the foci, and the asymptotes. So the vertices, how do we find those? Well, since the y squared comes first, we know we're going to be focusing along the vertical axis. So the vertices should have a y value. So it's going to be 0, comma, and our our a value of plus or minus 1. Okay, good. We have our vertices. Now what's next? The foci. Okay, so the foci, once again, since we're focusing along the vertical the vertical axis, we'll be looking at y values, and the foci comes from, how do we find that? We got to do c squared equals a squared plus b squared. So c is going to equal plus or minus the square root of plus or minus 1 squared plus or minus 3 squared. So c is going to equal plus or minus, and simplifying that out, we get 10. And that, just for approximating graphing purposes, is about 3.2. Okay, so we have the vertices, foci, a and b. What are we missing? Asymptotes. Okay, so we're missing the asymptotes. To find that, let's see, which formula do we use? Well, since the y squared value was first, we're going to use a divided by b this time. So then get y equals plus or minus 1 divided by 3x, and those are the equations for asymptotes. And once again, asymptotes are a line. Please make sure and label those lines. So, graphing. Let's go ahead, draw in that box first, find the a and b values. So our a values are 1 and 1, and then b values are 3 and 3. Okay, then let's go ahead and draw in the asymptotes. Okay, so the asymptotes are plus or minus 1 over 3. They got to cross through here, we know that much, on all the corners. So over 3 down 3, over 3 up 3, over 3 down 1. I'm just reading off the slope there. Okay, so trying to organize my iPad so I can draw this in well. Drawing in our dotted lines with the arrowheads. And then we're going to go ahead and graph it once we get them in. They don't need to be perfectly straight, but they should look like you're trying to draw a straight line. So that's going to be y equals 1 over 3x, and then y equals negative 1 over 3x. Okay, so we've drawn those in. What's missing? The vertices and the foci. Okay, so the vertices are at these values here. 0, 1, 0, negative 1. And then the foci. Those are at 0 plus or minus root 10, which is about 3.2. 1, 2, 3. So that's going to be 0, root 10. 1, 2, 3. About 0, negative root 10. And then let's go ahead and draw on a graph. And notice the graph doesn't actually touch the foci, so please keep that in mind. Oops, it should be going along. It shouldn't look like it's pulling away from the asymptote. It looks like it should be sucking towards the asymptote. A little hard to draw because this is such an angled item. Okay. But we can do this. And there we go. Not the best one, but it gives the main impression on what's happening with the graph. Make sure once again that there are curves because it is a curved graph. Alright, now let's look at example 3. Find the equation of a hyperbola with vertices 0, plus or minus 4, and passing through 2, 5. State the asymptotes and the foci. Sketch the graph. Okay, so we're given very little information, but what are we given? We're given that the vertices are 0, 4, and it passes through this point. Well, the one awesome thing I know about vertices is it tells you if the x is first or the y is first. How do I know? Well, since the value given has the y, or you could say the y is not 0, we know that the y squared value is first. So we minus the x squared value divided by something equal to 1. Then the question is, do I know what the a squared and the b squared values are? I know what the a squared is. That's this value right here. So that's plus or minus 4 squared. Let's go ahead and plug that in. So I know that's plus or minus 4 squared. Then the question is, do I know what the b value is? And the answer to that is we don't yet know what it is. But we are given an x and a y value. So if I were to plug that x and y value into my equation, then I could solve for b. So let's go ahead and do that. I'm going to go ahead and say solving for b. And then plugging in my x squared and my y squared, we get 5 squared over 16 minus 2 squared over b squared equals 1. And once again, our goal is to solve for b squared. That's the missing link. So we get 25 over 16 minus 4 over b squared equals to 1. Alright, so let's see. Let's move the 1 on one side and the b on the other. So it'll be 25 over 16 minus, and I'm going to go ahead in the same step, turn the 1 into 16 over 16. Oops, that's a b squared. Subtracting those two, we get 9 over 16 equals the 4 over b squared. Go ahead, cross multiply for solving. And then we'll get 9b squared equals, and 4 times 16. I'm just going to leave that for now. Dividing both sides by 9, I'll end up with b squared equals 64 divided by 9. Kind of a weird number, but that's what it is. Okay, so then that means my equation. Let's go ahead and do this. My equation, y squared divided by, and that's going to be 16, minus. Now, when I divide the x squared by the 64 over 9, we're going to end up taking the reciprocal, so we'll get 9x squared over 64 equals 1. And there we have our equation. So now, what are we missing for graphing? Well, we have our b squared value, which for graphing is going to be approximately about equal to, well, the b value. B value is going to be approximately equal to 2.6 or 2.7. So we have a and b. What are we missing? We're missing the foci, the asymptotes, and then also the vertices. So how do we find the foci? Oh, let's use the equation. C squared equals a squared plus b squared. So c squared is going to equal, and our a squared value is going to be 16, plus our b squared value, which is going to be 64 over 9. Adding those together, we'll end up with c squared equals 208 over 9. And then, moving our work out to the side here, c is going to equal plus or minus 4 root 13 over 3 when we simplify. So that's our foci. 0, comma, plus or minus 4 root 13 over 3. Okay, so we've labeled our foci. We've got our a and b values. What are we missing again? We're missing the vertex and the asymptotes. So go ahead and draw asymptotes here. Asymptote. Once again, labeling work really helpful, especially if you don't have as much space. So since the y was first, we know the a value is going to be on top. So it's going to equal plus or minus, and that'll be 4 divided by. Now our b value was the square root of 64 over 9. So that would be 8 over 3. So it's going to be plus or minus 8 over 3 x. Then y is going to equal plus or minus 3 over 2x. And the last thing is the vertex, but we're already given the vertex in the very beginning. We could rewrite it. Why not? You wouldn't need to if you're already given it. Okay, so we found them all. Let's go ahead, draw in the box. Okay, box. The b value is so weird. 8 divided by 3, I said roughly about 2.6. So 2.6, a little more than halfway. 2.6, a little more than halfway. And then the a value was 4. 1, 2, 3, 4. Oops, I just realized I did that on the wrong axes. Once again, we're focusing on the y, so the y values should be the larger ones. Okay, so it was 4. 1, 2, 3, 4. 1, 2, 3, 4. And then about 2.6, about 2.6. Drawing in our boxes. Ooh, this is not going to be that pretty, especially for the equations of the asymptotes. Okay, asymptotes, we have 3 over 2. Starting from the center, we always start for the center for the origin-centered ones. Down 3 over 2, down 3 over 2, up 3 over 2, up 3 over 2. Once again, just counting out the slope on my line. Arrowheads, and then the next one. So up 3 over 2, up 3 over 2, down 3 over 2, down 3 over 2. And labeling those. So y equals negative 3 over 2x, and y equals positive 3 over 2x. Almost done. Let's see. So right here we have our vertices. So that's going to be at 0, 4 and 0, negative 4. And then lastly, we now need to draw in our foci. So 4 root 13 divided by 3. That is such a weird item to graph, but that's about 4.8. Let me go ahead and write that in. It's about 4.8. Now that's not something I would leave on my graph. That's just for you to see. 0, negative 4.8, and 0, 4.8. Okay, and then graphing in our hyperbola. A lot easier to graph this one because it's not so narrow, like the last one we graphed. Once again, not going in the box, just touching on the vertice, and then getting sucked towards the asymptotes. Alright, last example for this section. Find the equation of a hyperbola with foci plus or minus 3, 0, and asymptotes y equals plus or minus half x. State the vertices, sketch the graph. Okay, once again, it's good to have all the formulas memorized because that gives you a great idea on what we know. So right now, we're told the foci and the asymptotes. Well, what do we know about the asymptote? Well, we know that 1/2 should equal in this case, either a divided by b or b divided by a. How do we know which one it is? And that answer comes from the foci. Which number are we given? Well, we're given an x value, which means we know we're going to be focusing along the x-axis, or the x squared is going to be first. We're going to be using this equation right here. So the question is, do we use a divided by b or b divided by a? And it's going to be b divided by a. That is the formula for asymptotes when the x value is first. So go ahead, not using that one, we're going to use the b divided by a. Alright. But we still need to figure out what a and b are. I can't assume that b is 1 and a is 2. So I'm going to use the work for the foci, or the information for the foci, and try and solve this. So we know that for the foci, c squared is supposed to equal a squared plus b squared. And we know the c value is plus or minus 3. Do I know a or b? I don't know it right now, but I could use this equation up here to solve for one of them, and then use substitution to put into the equation for the foci. Let's just go ahead and solve for a. Why not? Doesn't matter which one you choose. So plugging that in, we'll get 2b squared plus b squared. Then we get 9 equals 4b squared plus b squared. So that'd be 9 equals 5b squared. Which, when we solve, we get 9 divided by 5 equals b squared. Solving for b, we get plus or minus 3 over root 5 is b. Okay, and then how do we find out what a is? Let's go ahead and do solving for a. We know with our equation above that A is equal to 2 times B. So A is going to equal 2 times the plus or minus 3 over root 5, which means that A equals, let's see, 6 over root 5. And that would be the plus or minus 6 over root 5, which we'd still need to simplify into A equals plus or minus 6 root 5 over 5. We should do the same for the B, plus or minus 3 root 5 over 5. Alright, we found A and B, which means we can go ahead and rewrite our equation. So x squared divided by, and our A value was, well, that's going to be 36 divided by 5 when I square the A, minus y squared, that's going to be 9 divided by 5 equals 1. We got to simplify that though, because that's a complex fraction. We cannot leave it like that. Simplifying. And we get 5y squared over 9 equals 1. And there we have the equation for a hyperbola. And we have found the foci, or sorry, we're given the foci earlier. What else do we need? We have the asymptotes, we have the foci, we have the equation, we have... Oh, we don't have the vertices. Well, the vertices, that's pretty simple. We just use the A value, which is going to be plus or minus 6 root 5 over 5 comma 0. Once again, use the exact values, not approximates. Only use approximates for graphing. Speaking of graphing, let's go ahead and do that. So the approximates for B, when I approximate that, that's going to be about 0, 1.3, and 0, negative 1.3. And then approximates for the vertices, it's about 2.68 for the A values. So 2.68, about there for the A's. Let's go ahead and draw this really weird box in. Not the most beautiful numbers, definitely not fun to graph. And then drawing in the asymptotes, we have plus or minus 1 over x. So up 1 over 2. Up 1 over 2, up 1 over 2, down 2 over, okay. And then drawing that in. That's y equals the positive half, because it's going up. And then up, over, up, over, up, over. Once again, I'm just drawing in the slope here to get a better idea on how to draw my graph. Once again, it should pass through those corners. Ooh, down 1 over 2. Dotted lines. And the equations. Okay. Last things. Vertices and foci. Vertices we already kind of found. That should be 0, comma. 6 root 5 over 5. Not an easy number to write in. It's a negative. And then the foci, which we're given plus or minus 3. Now that, that is easy to graph. 0, negative 3, 0, 3. Okay, and last step, such a satisfying feeling. Oh gosh, we go through the number. Once again, it shouldn't look like it's going away from the asymptotes. It looks like it's going towards it, but it should not be crossing your asymptotes, so be careful. Arrowheads, and there we go. Whew, that one was definitely a lot of work, not the best numbers. But that is it for section 11.3. Other than that, we have one more section. You're doing great. Keep hanging in there. Alrighty, email me if you have any questions.